Polynomials. A polynomial in one variable x is an algebraic expression of the form p of x is equal to a n x power n plus a n minus 1 x power n minus 1 plus a n minus 2 x power n minus 2 plus dash 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 plus a2 x square plus a1 x plus a naught, where n is a non-negative integer and a naught comma a1 comma a2 dash 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 an are constants, that is real numbers. The highest power of x in a polynomial p of x is called the degree of the polynomial p of x. Suppose you consider any term in a given polynomial, say a2 x square. Here x square coefficient is a2. Here 2 is the degree of the polynomial. Suppose n is equal to 0. Say p of 0, that is p of 0, your polynomial equation p of 0 is equal to a naught x power 0, that is equal to x power 0 is equal to 1, a naught into 1, that is a naught. Here degree of the polynomial is 0. N is equal to 1, that is p of 1 is equal to a1 x power 1 plus a naught, that is a1x plus a naught. Here degree of the polynomial is 1, that is linear polynomial. Your condition should be a1 is not equal to 0 for linear polynomial. N is equal to 2, that is p of 2, that is equal to a2 x square plus a1x plus a naught. Here degree of the polynomial is 2, that is quadratic polynomial. Here condition should be a2 is not equal to 0. N is equal to 3, that is p of 3 is equal to a3 x cube plus a2 x square plus a1x plus a naught. Here degree of the polynomial is 3. Cubic polynomial, your condition is a3 is not equal to 0. Degree of a polynomial. The highest power of x in a polynomial p of x is called the degree of the polynomial p of x. Example, here p of x is equal to 5x plus 1 by 3 is a polynomial in variable x of degree 1. Here highest power of x is 1. So degree is 1. Next, p of y is equal to 3y square minus 5 by 2y plus 7 is the polynomial in variable y of degree 2. Here highest power of y is 2. So degree is equal to 2. Types of polynomials. 1. Linear polynomial. A polynomial of degree 1 is called linear polynomial. Examples. 1. F of x is equal to 2x plus 4. 2. G of y is equal to root 7y minus 1. Generally, any linear polynomial in variable x of the form f of x is equal to ax plus b, where a comma b are real numbers and a is not equal to 0. F of x is 2x plus 4. Here variable is x. G of y is equal to root 7y minus 1. Here variable is y. Let us draw the graph of f of x is equal to 2x plus 4, that is shown in figure. So let it be f of x is equal to 2x plus 4. F of minus 2 is equal to minus 2 into 2 minus 4 plus 4 is equal to 0. So input value is minus 2, output value is 0. Your corresponding point is minus 2 comma 0. So minus 2 comma 0 plot here, that is on the x-axis. F of 0 is equal to 2 into 0 plus 4, which is equal to 4. Input value is 0, output value is 4. So 0 comma 4. Here plot second point 0 comma 4, that is on the y-axis. Join 1 and 2, which is a straight line. 2. Quadratic polynomial. A polynomial of degree 2 is called quadratic polynomial. Examples. 1. F of x is equal to 5x square plus 3x minus 7 by 5. Here degree is 2. 2. F of x is equal to x square. Here degree is 2. Generally, any quadratic polynomial in variable x of the form f of x is equal to ax square plus bx plus c, where a comma b comma c are real numbers and a is not equal to 0. Here figure shows quadratic polynomial, that is f of x is equal to x square. So give some input values, say 0, f of 0 is equal to 0 square, that is 0. Input value is 0, output value is 0. So 0 comma 0, first point, plot first point. Next, f of 1 is equal to 1. 1 square is 1. So 1 comma 1, plot second point. F of minus 1 is equal to minus 1 whole square is 1. So minus 1 comma 1. Plot third point. F of 2 is equal to 2 square 4. So 2 comma 4. This is fifth point. 2 comma 4. This is fifth point. F of minus 2 is equal to 4. So minus 2 comma 4. This is sixth point. So joining all these points, you will get a curve. That curve is a quadratic polynomial. The shape of this curve is parabola, which is symmetrical about y-axis. 3. Cubic polynomial. A polynomial of degree 3 is called cubic polynomial. Examples: 1. F of x is equal to x cube. 2. F of x is equal to x cube minus x square, which is equal to x into x minus 1 into x plus 1. Generally, any cubic polynomial in variable x of the form f of x is equal to ax cube plus bx square plus cx plus d, where a comma b comma c comma d are real numbers and a is not equal to 0. Here first figure shows f of x is equal to x cube, that is cubic polynomial, degree is 3. Second figure shows f of x is equal to x cube minus x square. Here degree 3. Here figure 1 shows intersecting point on x-axis is only 1. Figure 2 shows 3 intersecting points on the x-axis, say 1, 2, 3. So here we have 3 points, x coordinate of each point, which is the 0 of the given polynomial. So here we have degree 3. So degree 3 means you have number of zeros 3. Value of a polynomial at a given point. If p of x is a polynomial in x and alpha is a real number, then the value obtained by putting x is equal to alpha in p of x is called the value of p of x at x is equal to alpha. Example: if p of x is equal to 5x square minus 4x plus 2, then its value at x is equal to 2 is p of 2 is equal to 5 into 2 square minus 4 into 2 plus 2 is equal to 5 into 2 square is 4, 4 minus 4 into 2 plus 2 is equal to 5 4 is 20 minus 4 2 is 8 plus 2 is equal to 20 minus 8, 12 plus 2 is equal to 12 plus 2, 14. Thus, the value of p of x at x is equal to 2 is 14. 0 of a polynomial. A real number k is said to be a 0 of a polynomial p of x if p of k is equal to 0. Example: in the given polynomial p of x is equal to 5x plus 7, if we put x is equal to minus 7 by 5, then p of minus 7 by 5 is equal to 5 into minus 7 by 5 plus 7 is equal to 5 gets cancelled, minus 7 plus 7 is equal to minus 7 plus 7 is equal to 0. At x is equal to minus 7 by 5, the value of p of x is equal to 0. So therefore, minus 7 by 5 is a 0 or root of a polynomial p of x is equal to 5x plus 7. Every quadratic polynomial can have at most 2 zeros. However, there exist some quadratic polynomials which do not have any real zero. Example: x square plus x plus 1. Let p of x is equal to x square plus x plus 1. P of x is equal to ax square plus bx plus c. Comparing these two, here x square coefficient is 1, a is equal to 1, x coefficient is 1, so that is b is equal to 1. Constant value is 1, that is c is equal to 1. Now calculate b square minus 4ac, that is equal to b square, that is 1 square. minus 4 into 1 into 1 is equal to 1 square is 1 minus 4 into 1 is 4 is equal to 1 minus 4 is minus 3 is less than 0. Therefore, x square plus x plus 1 do not have any real 0. Try another polynomial. P of x is equal to 3x square plus 4x plus 2. Here b is equal to 4, that is b square 16. 4ac, 4 into 3, 12, 12 into 2, 24. So therefore, 16 is less than 24. So b square is less than 4ac. So therefore, 3x square plus 4x plus 2 do not have any real zeros. Represent the linear polynomial 2x plus 3 on the graph paper and find the zero. Let y is equal to p of x is equal to 2x plus 3. To draw its graph, we need two or more than two values of y corresponding to the different values of x. At x is equal to minus 2, the value of the polynomial p of minus 2 is equal to 2 into minus 2 plus 3. 2 into minus 2, that is minus 4 plus 3. Minus 4 plus 3 is equal to minus 1. At x is equal to 0, the value of the polynomial p of 0 is equal to 2 into 0 plus 3 is equal to 2 into 0, 0 plus 3. 0 plus 3, 3. At x is equal to 1, the value of the polynomial is p of 1 is equal to 2 into 1 plus 3 is equal to 2 plus 3. 2 plus 3, 5. Consider the following table for graph. At x is equal to minus 2, corresponding value of polynomial is minus 1. At x is equal to 0, value of the polynomial is 3. At x is equal to 1, value of the polynomial is 5. Draw x-axis, y-axis, 1, 2, 3, 4, 1, 2, 3, 4, 5, minus 1, minus 2. Here minus 1, minus 2. So now plot points on the graph sheet. First point is A, minus 2, comma, minus 1. Minus 2, minus 1. First point. Second point B, 0, comma 3. X 0, Y 3. Third point 1, comma 5. X 1, Y 5. A, minus 2, comma, minus 1. B, 0, comma 3. C, 1, comma 5. Now join A, B, C. Join A, B, C, which is a linear polynomial, that is 2x plus 3. 2x plus 3. By observing, this line is intersecting on the x-axis at point x is equal to minus 1.5, which is the 0 of the given polynomial. Therefore, 0 of the polynomial is minus 1.5. Present the quadratic polynomial x square minus 2x minus 3 on the graph paper and find zeros. Let y is equal to p of x is equal to x square minus 2x minus 3. Here calculate polynomial value at x is equal to minus 2, that is p of minus 2 is equal to minus 2 whole square minus 2 into minus 2 minus 3 is equal to minus 2 whole square 4 minus into minus plus 2 into 2 4 minus 3 is equal to 4 plus 4 8 minus 3, that is 5. Polynomial value at x is equal to minus 1, that is p of minus 1 is equal to minus 1 whole square minus 2 into minus 1 minus 3 is equal to minus 1 whole square is 1 minus into minus plus 2 into 1 is 2 minus 3 is equal to 1 plus 2 3. 3 minus 3 0. At x is equal to 0, polynomial value p of 0 is equal to 0 whole square minus 2 into 0 minus 3 is equal to 0 square is 0 minus 2 into 0 is 0 minus 3 is equal to minus 3. Polynomial value at x is equal to 1, that is p of 1 is equal to 1 square minus 2 into 1 minus 3 is equal to 1 square is 1 minus 2 minus 3. 1 minus 5, that is minus 4. P of 2 is equal to 2 square minus 2 into 2 minus 3 is equal to 2 square 4 minus 4 minus 3 is equal to 4, 4 gets cancelled, minus 3. P of 3 is equal to 3 square minus 2 into 3 minus 3 is equal to 3 square 9 minus 3 to the 6 minus 3 is equal to 9 minus 6 3, 3 minus 3 0. P of 4 is equal to 4 square minus 2 into 4 minus 3 is equal to 4 square 16 minus 4 to the 8 minus 3 is equal to 16 minus 8, 8, 8 minus 3, 5. Draw x-axis, y-axis. Here take 1 centimeter is equal to 2 units on the x-axis and 1 centimeter is equal to 2 units on the y-axis. 2, 4, 6, 2, 4, 6, 8. Minus 2, minus 4, minus 6, minus 2, minus 4, minus. Plot first point as minus 2, 5. X is equal to minus 2, y is equal to 5. Next point minus 1, 0. X is equal to minus 1, y value 0. Minus 1, 0. X is equal to 0, y is equal to minus 3. X is equal to 1, y is equal to minus 4. X is equal to 2, y is equal to minus 3. X is equal to 2, y is equal to minus 3. X is equal to 3, y is equal to 0. X is equal to 3, y is equal to 0. X is equal to 4, y is equal to 5. X is equal to 4, y is equal to 5. So join all these points by a smooth curve. So which is a quadratic polynomial? P of x is equal to x square minus 2x minus 3. Here curve intersecting on the x-axis at 2 points at x is equal to minus 1 and at x is equal to 3. At x is equal to minus 1, value of the polynomial is 0. At x is equal to 3, value of the polynomial is 0. So therefore, the zeros of the given quadratic polynomial are minus 1 and 3. Present the cubic polynomial x cube minus 4x on the graph paper and find zeros. Let y is equal to p of x is equal to x cube minus 4x. Here calculate the polynomial value at x is equal to minus 2. That is p of minus 2 is equal to minus 2 whole cube minus 4 into minus 2 is equal to minus 2 whole cube, that is minus 8, minus into minus plus 4 to the 8, minus 8 plus 8 is equal to 0. Polynomial value at x is equal to minus 1, that is p of minus 1 is equal to minus 1 whole cube minus 4 into minus 1 is equal to minus 1 whole cube, that is minus 1, minus into minus plus 4 into 1, 4, minus 1 plus 4, that is equal to 3. P of 0 is equal to 0 cube minus 4 into 0 is equal to 0 minus 0 is equal to 0. P of 1 is equal to 1 cube minus 4 into 1 is equal to 1 cube is 1 minus 4 into 1, 4, 1 minus 4 equal to minus 3. P of 2 is equal to 2 cube minus 4 into 2. 2 cube 8 minus 4 to the 8. 8 minus 8 is equal to 0. Represent these values on the table shown here. Draw x-axis, y-axis. Intersection point is origin. Here take 1 centimeter is equal to 1 unit on the x-axis and 1 centimeter is equal to 1 unit on the y-axis. Axis, y-axis. 1, 2, 3, 1, 2, 3, 4. Minus 1, minus 2, minus 3. Minus 1, minus 2, minus. Plot first point minus 2 comma 0. X is minus 2, y value 0, minus 2, 0. X value minus 1, y value 3. X value minus 1, y value 3. X is equal to 0, y is equal to 0. X is equal to 0, y is equal to 0. X is equal to 1, y is equal to minus 3. X is equal to 1, y is equal to minus 3. X is equal to 2, y is equal to 0. X is equal to 2, y is equal to 0. So join all these points by a smooth curve. So here curve shows cubic polynomial. This curve is intersecting on the x-axis at 3 points, that is x is equal to -2, 0 and 2. So therefore zeros of the polynomial are -2, 0, 2. Relation between zeros and coefficients of a polynomial, formation of quadratic and cubic polynomials. Linear polynomial. If k is 0 of a polynomial, p of x is equal to ax plus b, a is not equal to 0, then p of k equal to 0. A into k plus b is equal to 0. Ak is equal to minus b. K is equal to minus b by a. Thus, 0 of the linear polynomial p of x is equal to ax plus b is k is equal to minus b by a. Quadratic polynomial. In general, let alpha and beta be the zeros of the quadratic polynomial p of x is equal to ax square plus bx plus c, comma, a is not equal to 0, comma, then by factor theorem x minus alpha and x minus beta both are the factors of p of x. Therefore, ax square plus bx plus c is equal to, here divide each term by x square coefficient, that is a, equal to x square plus b by a into x plus c by a is equal to x minus alpha into x minus beta. Product of two factors is equal to x into x minus beta minus alpha into x minus beta is equal to x square minus x into beta beta x minus alpha into x alpha x minus into minus plus alpha beta is equal to x square minus x common, that is minus x into alpha plus beta plus alpha beta. On comparing the coefficients of x and constant term from both sides, we get x coefficient right hand side is minus alpha plus beta is equal to b by a. Therefore, alpha plus beta is equal to minus b by a. Equation 1. Comparing constant term, alpha beta is equal to c by a. Equation 2. So therefore, sum of zeros alpha plus beta is equal to minus b by a, that is equal to minus of coefficient of x divided by x square coefficient. Product of zeros alpha beta is equal to c by a, that is equal to constant term divided by x square coefficient. Cubic polynomial. In general, comma, let alpha, comma, beta and gamma be the zeros of the cubic polynomial p of x, comma, is not equal to 0. Then by factor theorem, x minus alpha, comma, x minus beta and x minus gamma are the factors of p of x is equal to ax cube plus bx square plus cx plus d. Therefore, ax cube plus bx square plus cx plus d take common x cube coefficient a, so that is equal to ax cube plus bx square plus cx plus d by a, which is equal to x cube plus b by x square plus c by ax plus d by a is equal to product of three factors, that is x minus alpha into x minus beta into x minus gamma is equal to bracket open x into x minus beta minus alpha into x minus beta bracket closed into x minus gamma is equal to bracket open x square minus beta x minus alpha x plus alpha beta bracket closed into x minus gamma is equal to x into bracket open x square minus beta x minus alpha x plus alpha beta bracket closed minus gamma into bracket open x square minus beta x minus alpha x plus alpha beta bracket close is equal to x into x square x cube minus x into beta x x square minus x into alpha x square plus x into alpha beta x minus gamma into gamma x square minus into minus plus gamma into beta gamma x minus into minus plus gamma into gamma alpha x minus into plus minus gamma into alpha beta gamma is equal to x cube minus alpha plus beta plus gamma into x square plus alpha plus beta gamma plus gamma alpha into x minus alpha beta gamma. And comparing the coefficients of x square comma x and constant term both sides, we get minus alpha plus beta plus gamma is equal to b by a. Alpha plus beta plus gamma is equal to minus b by a, equation 1. Comparing x coefficient, that is alpha beta plus beta gamma plus gamma alpha is equal to c by a, equation 2. Comparing constant term, that is minus alpha beta gamma is equal to d by a. Alpha beta gamma is equal to minus d by a, equation 3. So therefore, sum of zeros alpha plus beta plus gamma is equal to minus b by a. So that is equal to minus of x square coefficient divided by x cube coefficient. Sum of product of two zeros taken in order, that is alpha beta plus beta gamma plus gamma alpha is equal to c by a, is equal to coefficient of x divided by x cube coefficient. Product of zeros alpha beta gamma is equal to minus d by a, that is equal to minus of constant term divided by x cube coefficient. Formation of quadratic polynomial. If alpha and beta are the zeros of a quadratic polynomial, then quadratic polynomial is x square minus sum of zeros into x plus product of zeros. That is x square minus alpha plus beta into x plus alpha beta, where sum of zeros is equal to alpha plus beta and product of zeros is equal to alpha beta. Find the quadratic polynomial whose zeros are 6 and minus 3. Let alpha is equal to 6, beta is equal to minus 3. Sum of zeros is equal to alpha plus beta is equal to 6 minus 3 is equal to 6 minus 3 is equal to 3. Product of zeros alpha beta is equal to 6 into minus 3, that is equal to minus 18. Quadratic polynomial is given by is equal to x square minus alpha plus beta into x plus alpha beta is equal to x square minus 3x minus 18. Formation of cubic polynomial. If alpha comma beta and gamma are the zeros of a cubic polynomial, then cubic polynomial is x cube minus sum of zeros into x square plus sum of product of two zeros into x minus product of zeros, that is x cube minus alpha plus beta plus gamma into x square plus alpha beta plus beta gamma plus gamma alpha into x minus alpha beta gamma, where sum of zeros is equal to alpha plus beta plus gamma. Sum of the product of zeros taken two at a time is equal to alpha beta plus beta gamma plus gamma alpha. Product of zeros is equal to alpha beta gamma. Find the cubic polynomial whose three zeros are 3 comma 1 comma and minus 1 by 3. Let alpha is equal to 3, beta is equal to minus 1, gamma is equal to minus 1 by 3. Sum of zeros, that is alpha plus beta plus gamma is equal to 3 minus 1 plus minus 1 by 3 is equal to 3 minus 1 2 plus into minus minus 1 by 3 is equal to 3 to the 6 minus 1 5 divided by 3. Sum of product of two zeros taken in order, that is alpha beta plus beta gamma plus gamma alpha is equal to 3 into minus 1 plus minus 1 into minus 1 by 3 plus minus 1 by 3 into 3 is equal to 3 into minus 1, that is minus 3, minus into minus plus 1 into 1 by 3 1 by 3 plus into minus 3 gets cancelled, 1 is equal to minus 3 minus 1, that is minus 4 plus 1 by 3 is equal to minus 4 into 3 minus 12 plus 1, that is minus 11 divided by 3. Product of three zeros alpha beta gamma is equal to 3 into minus 1 into minus 1 by 3 is equal to 3 gets cancelled, minus 1 into minus 1, that is plus 1. Cubic polynomial is equal to x cube minus alpha plus beta plus gamma into x square plus alpha beta plus beta gamma plus gamma alpha into x minus alpha beta gamma is equal to x cube minus 5 by 3x square plus minus 11 by 3x minus 1 is equal to LCM 3. So that is 3x cube minus 5x square minus 11x minus 3. Required cubic polynomial is equal to 3x cube minus 5x square minus 11x minus 3.